kinetic energy of reactant molecules, distribution. According to the collision theory of chemical reactions, only a fraction of the reactant molecules will have the required energy to result in effective collisions, that is, collisions that produce the product. It is not possible to measure or predict the behavior of one molecule. Instead, we predict the number of molecules in a reaction mixture having a certain kinetic energy. The curve shown here depicts the number of molecules that have a certain kinetic energy. This is called the distribution of molecular energies of reactant molecules. The maximum number of molecules having the same energy corresponds to the peak of the curve. This gives us the most probable kinetic energy. The activation energy of the reaction is independent of the kinetic energy distribution of the molecules of the reactant. Only a very small number of molecules have sufficient energy, greater than or equal to the activation energy, to undergo the formation of the activated complex. All other molecules do not have sufficient energy to overcome the activation energy required for this reaction. When the temperature is increased, the kinetic energy of all molecules increases. Observe that the peak of the graph has shifted to the right. That is, a large number of molecules have high kinetic energy. The number of molecules that have kinetic energy greater than or equal to the activation energy of the reaction increases dramatically. This results in more number of effective collisions, which increases the rate of reaction. When a catalyst is added, the activation energy of the reaction is reduced. The catalyst often provides an alternate pathway for the reaction, with the activated complex differing from the activated complex in an uncatalyzed reaction. On the molecular energies distribution graph, the curve is not affected by addition of catalyst. The activation energy is lowered, which results in a greater proportion of molecules possessing a kinetic energy that is greater than the activation energy for the catalyzed reaction. A catalyst performs this without getting consumed in the chemical reaction. A small amount of catalyst can catalyze a large number of reactions at the molecular level without getting used up. A catalyst cannot make a reaction that is not feasible happen. It only speeds up the reaction. A catalyst also doesn't affect the amount of product formed.
Starting to feel it? Now go master it with